If we know the point group of the molecule, we can easily determine what are the symmetry elements present in that molecule. And if we know the symmetry elements present in that molecule, we can introduce various substituents and introduce defects in that molecule and can change the properties and applications of the molecule. Hello friends, I am Dr. Aniket Paunoji and you are watching Basic Chemistry. Most of the molecules possess not only one but many symmetry elements. A point group is a collection of all symmetry operations that describe overall symmetry of the molecule. Or we can say that a point group is a collection of all symmetry operations that can be carried out about a unique point on the molecule, and all these are related to one another by certain rules. Let's see what are the different types of point groups. There are total 4 types of point groups. The first one is lower symmetry point group, the second is C-type point group, the third is D-type point groups, and the last one is higher symmetry point groups. Let's begin with lower symmetry point groups. Consider thioformic acid. If you see this molecule, there are no any symmetry elements present in the molecule, but if this molecule is rotated by 360 degree around a point, we can get the same image. Therefore, we can say that the point group of this molecule is C1 type. As there is only one element of symmetry is present, that is identity element, and if we rotate the molecule through 360 degree or 0 degree, we will get the same image. Therefore, only one identity element is present in that molecule. Such molecules are classified into C1 type. Let's see some more examples. Here I am taking the example of methanol and 1-bromo-3-chlorobenzene. In case of methanol, there is a plane which bisects the molecule into two halves which are mirror images of each other. Such mirror plane is called as sigma vertical plane. In case of 1-bromo-3-chlorobenzene, it contains a plane which contains all the atoms inside that plane. Such plane is called as horizontal plane. So, in these molecules, apart from these planes, there are no symmetry elements present in this molecule apart from identity element. So here they contain identity element and vertical plane or horizontal plane. Such type of molecules are classified into CS point group. Let's see some more examples. Now I am taking the example of 1,2-dibromo, 1,2-dichloroethane. This is the model of this molecule. So 1,2-dibromo, 1,2-dichloroethane. Now in this molecule, you can see there is an inversion center present at that molecule. Inversion center means there are same type of atoms at opposite side on equal distance. So if you see this molecule, these two atoms are on the opposite side at equal distance, and similarly the other ones. There is other way of writing the same molecule. You can see the same type of atoms are on the opposite side at equal distance. So in this molecule, there is inversion center present, identity element is present, and there is rotation reflection axis is also present. So if you see this molecule from this angle, now I can take the rotation and then a reflection in this plane, so I will get the same image. So that means rotation, reflection, I am getting the same image. That means rotation reflection axis, that is S2 axis, is present in this molecule. So these type of molecules are classified into CS point group, or they are also called as S2N point group. Let's move to the next type of point groups, that is C type of point groups. Let's see the example of triphenylphosphine and trisglycinato cobalt 3 complex. In these molecules, there is C3 axis present in these molecules. So we can rotate the molecule through 120 degree to get the same image. And if we rotate the molecule through 120 degree 3 times, we will get the identical image. That is how C3 axis is present in these molecules. So in these molecules, there is identity element present, C3 axis is present, and such type of molecules are classified as C3 type point groups. To understand C type of point groups, let's see some more examples. Let's see the example of H2O molecule, which is the simplest molecule. In this H2O molecules, identity element is present. As the identity element is present in all the molecules, apart from the identity element, there is C2 rotational axis. That means if we pass an axis through this and if we rotate the molecules through 180 degree, we will get an indistinguishable image. If we rotate the molecule once again through 180 degree, we will get the identical image. That means C2 proper rotational axis is present in this molecule. Then there is a sigma vertical plane present in the molecule. This plane which divides the molecule into two halves, which are mirror images of each other. There is another plane present in this molecule. This is also vertical plane. So remember, this is not a horizontal plane. The vertical plane is the plane which is parallel to the principal rotational axis. Principal rotational axis is C2. So this plane is also parallel. This plane is also parallel to the molecule. If the plane would have been like this, that is perpendicular to the principal rotational axis, that would have been horizontal plane. But this plane contains all the atoms, but it is parallel to the principal rotational axis. So therefore this is also vertical plane. This is how there are two vertical planes present in this molecule. Now if we collect all the symmetry operations, that is identity element, proper rotational axis and two vertical planes, therefore the point group of the molecule is C2V. So this C2V describes the molecule as there is C2 proper rotational axis present and two vertical planes present in that molecule. Let's see the example of ammonia. Ammonia is very simple molecule. This is a lone pair present in this molecule and there are three hydrogens present. Now in this molecule an identity element is present. Then there are C3 rotational axis, that is this axis is present around which we can rotate the molecule like this and you can get an indistinguishable image. After proper rotational axis, there is vertical plane present in this molecule. This is the first vertical plane present which divides the molecule into two halves. Similarly, second vertical plane and the third vertical plane. So this is the second vertical plane and third vertical plane. So in case of ammonia, you can see an identity element is present, C3 proper rotational axis is present and three vertical planes are present. So identity element, C3 and three vertical planes. Therefore, the point group of the molecule is C3V. So C3V describes C3 is the principal axis and there are three vertical planes present in that molecule. Now can you see this molecule? This is the example of xenon tetrafluoride. There are four fluoride atoms in one plane and there is one lone pair present in this molecule. Now let me know what is the point group of this molecule and mention your answer in the comment box. So such type of molecules are classified into CNV type, that is CNV point group. Next example in C type of point group is dichloroethane. In case of dichloroethane, apart from identity element, if you see this molecule, these two are the chlorine atoms and these two are hydrogen atoms. If you rotate the molecule through 180 degree, you will get an indistinguishable image. So this is the rotational axis around which you can rotate and you can get an indistinguishable image. If you rotate the molecule once again, you will get identical image. So this axis is called as C2 rotational axis. Now there is one horizontal plane present in this molecule. This is the plane I am talking about. So this plane contains all the elements and this plane is perpendicular to the principal rotational axis. So this plane is called as horizontal plane. Now there is one more symmetry element present in this molecule, that is inversion center. So there are same type of atoms present in this molecule at opposite side at equal distance. So if you see this molecule, these two are the same elements present at the opposite side. These two are also same at opposite side at equal distance. So the total symmetry elements present in this molecule are identity element, C2 rotational axis, horizontal plane. Therefore, the point group of this molecule is C2H point group. Next example we can take is boric acid. So in case of boric acid, apart from identity element, there is C3 rotational axis present in this molecule. That means you can rotate the molecule and through 120 degree to get an indistinguishable image. So therefore C3 rotational axis is present. Then there is a horizontal plane which contains all the elements. So therefore a sigma horizontal plane or sigma H is present in this molecule, and therefore the point group of the molecule is C3H. So these type of molecules are classified into CNH type of point groups. So we have completed all C type of point group molecules. Let's move to the D type of point group. In case of D type of point group, there are NC2 axis. There are NC2 axis in addition to the principal rotational axis. For example, in a molecule, if there is C2 principal rotational axis is present, then there will be two C2 axis perpendicular to the principal rotational axis will be present. If in a molecule there is C3 as principal rotational axis, there will be three C2 axis perpendicular to the principal C3 rotational axis. So such type of molecules are classified as DN type of molecules or DN point groups. To understand this, let's take an example of ethene molecule. This is the model of ethene molecule. Now here you can easily identify that there is an inversion center present at the molecule. Then there is a C2 rotational axis, so you can rotate the molecule like this to get an indistinguishable image, or you can rotate the molecule like this to get an indistinguishable image. So this is the first C2 axis perpendicular to the principal rotational axis. We have considered this as principal rotational axis. So if you rotate the molecule like this, so this will be perpendicular to the principal rotational axis. The second C2 axis will be like this. So this is the another C2 axis which is perpendicular to this C2 axis of rotation. So this is the first one, and this is the second one, C2 axis, which will be perpendicular to the principal rotational axis. In addition to this, there is a vertical plane. So there is a vertical plane which divides the molecule into two halves, which are mirror images. Then there is another vertical plane like this, which divides the molecule into two halves. So these are the two vertical planes present in the molecule, and there is third plane like this. So this is the third plane, which is a horizontal plane, because this plane contains all the atoms, and this plane is perpendicular to the principal rotational axis, that is this C2 axis. So therefore this is a horizontal plane, and these two are vertical planes. So to summarize, this molecule contains identity element. Then there is an inversion center at the center. Then there is a C2 which we have considered as principal rotational axis, and there are two C2 axes perpendicular to the principal rotational axis. There are two vertical planes, and there is a horizontal plane. So if you collect all these symmetry operations, the point group of the molecule is D2H point group. So such type of molecules are classified as DNH type. That is, they contain horizontal plane in addition to the vertical planes. So these type of molecules are classified as DNH point group. To understand this DNH point group, let's take one more example. Let's take the example of boron trichloride. This is the molecule boron trichloride. These three are the chlorine atoms. Now in this boron trichloride, there is a principal rotational axis through which you can rotate the molecule to get an indistinguishable image. So this is C3 rotational axis. Then there is a C2 rotational axis through which you can rotate like this to get an indistinguishable image. So this is the first C2 axis, this is the second C2 axis, and this is the third C2 axis. So first C2 is like this, second C2 is like this, and the third C2 is like this. So there are three C2 axes perpendicular to the C3 principal rotational axis. So this is how there are three C2 axes present in the molecule. Now there is a vertical plane, first vertical plane, second vertical plane, and third vertical plane. So first vertical plane, second vertical plane, and third vertical plane, which divides the molecule into two halves, which are mirror images of each other. And there is one more plane which is perpendicular to the principal rotational axis. So this is the principal rotational axis, and this is the plane I am talking about. This plane is perpendicular to the principal rotational axis. So this plane is called as horizontal plane. So to summarize this molecule contains identity element, C3 rotational axis, that is the principal rotational axis, 3 C2 axis perpendicular to the principal rotational axis, 3 vertical planes and a horizontal plane, Therefore, this type of molecule is classified into D3H point group. Now, can you calculate the point group for this molecule? Mention your answer in the comment box. To understand this in more detail or the D type of point group, let's take the example of xenon tetrafluoride. So this is the model of xenon tetrafluoride. These white ones are the fluorine atoms and these two are the lone pairs present in xenon tetrafluoride. So in xenon tetrafluoride there is a C4 axis. So if you hold the molecule like this and if you rotate the molecule through 90 degree, you get indistinguishable image. So this is C4 rotational axis present in this molecule. Now apart from this C4, there are 4 C2 axis present in this molecule. This is the first C2 axis, this is second C2 axis, this is the third C2 axis and this one is the fourth C2 axis. So I am talking about if you hold the molecule like this, so this is the principal rotation, C4 rotational axis. Now if you rotate the molecule like this, you get an indistinguishable image. If you rotate the molecule like this, you get an indistinguishable image. So this is the second C2 axis. Now hold the molecule like this and rotate the molecule like this, you will get the third C2 axis. And if you rotate the molecule like this, you will get the fourth C2 axis. This is how there are total 4 C2 axes present in this molecule. Now apart from these C2 axes, there is a vertical plane which divides the molecule into two halves. So this is how the molecule will get divided. So this is the first vertical plane. This is the second vertical plane present in the molecule. So there are total 2 vertical planes which divides the molecule into two halves which are mirror images of each other. Now one more plane is present in this molecule, that is the dihedral plane. In previous videos I have already explained what is a dihedral plane. If you have not watched that video, please click on the above link and watch that video to understand what is dihedral plane. A dihedral plane is the one which divides two perpendicular C2 axes and doesn't contain any other atom. So this is a dihedral plane and one more dihedral plane is present. So this is the first dihedral plane and this is the second dihedral plane present in the molecule. So there are 2 dihedral planes present in this molecule and one more plane, that is this one, which contains all the atoms. So this is a horizontal plane present in the molecule. To summarize, we have identity element and inversion center. As there are atoms on the opposite side at equal distance, there is an inversion center. Then this is the C4 rotational axis which we have considered as principal rotational axis. 4 C2 axes which are perpendicular to C4 axis, 2 vertical planes, a horizontal plane and 2 dihedral planes. So if this molecule, the C4 axis is present in the molecule, S2 is also present and S4 is also present, that is improper rotational axis. If you have not watched my earlier video on improper rotational, please click on the above link and understand what is improper rotational axis. So all these symmetry operations are present in this xenon tetrafluoride. Therefore point group of this molecule is D2D. As there are 2 dihedral planes, therefore the point group is D2D and these type of molecules are classified into D and D type of point group. To understand D type of point groups, let's take one more example of tris-ethylene diamine cobalt 3 complex. So you can see in a model, this is the model of tris-ethylene diamine cobalt 3 complex. In this complex there is C3 rotational axis as the principal rotational axis. Now look at the model like this. So if you rotate the molecule like this, you will get same image. So this is C3 rotational axis. So C3 rotational axis is the principal rotational axis and there are 3 C2 axes present in this molecule which are perpendicular to the principal rotational axis. To understand this, sometimes it becomes very difficult to understand a molecule on a screen, but on a 3D model you can better understand what are the different symmetry elements present in the molecule. So the first was the C3 rotation. To understand C3, we have to hold the molecule like this and you can get an indistinguishable image. To understand C2, I will hold the molecule like this and if I rotate to 180 degree, I will get the same image. So this is the C2 axis and there are 3 C2 axes present in this molecule. Now if you see, Now, apart from this C3 and C2, there are no any planes present in this molecule. So there is a C3 principal axis present and 3 C2 axis perpendicular to C3 axis. No sigma horizontal plane, sigma vertical plane or sigma dihedral plane. So these type of molecules are classified as D3 type point group, or the point group of this molecule is D3. And such type of molecules are classified into Dn type of point group. We have completed all molecules in D type of point group. Let's move to the next type of point group, that is higher symmetry point groups. There are certain geometries like tetrahedron, cubic, octahedron, isosahedron or dodecahedron. There are many symmetry elements, symmetry operations present in each molecule. So these molecules are classified into higher symmetry point groups. In this video it is very difficult to cover all these molecules. I'll need a separate video to explain each molecule. But when there are many symmetry elements present in one molecule, these molecules are classified into higher symmetry point groups. Now it is very important to identify what is the point group of any molecule. And on the internet there are many charts available like this, which helps to identify what is the point group of that molecule. In these charts you can proceed stepwise what is the type of symmetry element present or not present, and you can arrive at a decision what is the point group of that molecule. But in a competitive exam, it is very important to answer it within 5 seconds or 10 seconds, that is to identify a point group. And to identify that, imagination is very important, and you should practice different molecules to identify what is the point group of that molecule. I hope you followed how to determine point group of any molecule. If you like my video, click on like, do share and subscribe my channel. Don't forget to press the bell icon to get the updates of my new videos, and keep watching Basic Chemistry. Thank you.